Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. We hope you have a great day. In this video, we will be covering about applications of differentiations on two topics, which is related rates and minimum and maximum problems. Before that, here are our fellow group members who have contributed their time and energy in creating this video. So, what is related rates? Related rates problem involves two or more variables that change at the same time, possibly at different rates. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. It usually respect to time because most of the time it is usually respect to time. And for example of these related rates, if a balloon is being filled with air, both the radius of the balloon and the volume of the balloon are increasing at the same time. So here we are for the related rates problem statement. A conical water tank has a radius of 3 cm at the top and 15 cm height as shown below. Water flows into the tank at a rate of 6 cubic centimeter per second. So here we are given the volume of cone, which is 1/3 pi r square h. So we have two problems here, which is show that the volume of water is given by V equals to pi h cube per 75. And the second one is show how fast is the height changing at an instant when the height of the water is 5 cm.
Question number 1, we must prove the volume of water is V equal pi h cube over 75. So, given R is equal 3 cm and H equal 15 cm. So, R over H is equal 3 over 15. So, that we move the H to right hand side and we get 3H over 15. And we simplify that and we get H over 5. So we replace the R we get in the volume of the cone. So we get 1 over 3 multiplied with 5 in bracket H over 5 square multiplied with H. So we solve and we get pi H cube over 75. So we prove that. Number 2, given water flow into the tank at a rate of 6 cubic centimeter per second. So dV over dt is equal 6. dH over dt, we must find that when H equal 5. So dH over dt equal dH over dV multiplied with dV over dt. We get the dV over dH equal pi h square over 25. So dH over dt equal in bracket 1 over pi h square over 25 multiplied with 6, and we get 6 over pi h square over 25. We replace the h with 5 in the dH over dt and we get 6 over pi multiplied with 5 square over 25, and we get 625 pi over 25, and we solve, we get 6 over pi centimeter per second.
What is apply maximum and minimum problems? Apply maximum and minimum problem is the process of searching for maximum or minimum values is called optimization. It is also known collectively as extreme, the largest and smallest value of the function, either within a given range or on the entire domain. There are 3 steps. First one is find the derivative. The second one is let the derivative equal to 0 and find the value of the variables. The third step is if second derivative more than 0 is minimum value. Another one is if second derivative below than 0, it means maximum value. Apply maximum and minimum problems. Problem statement. Figure shows a closed rectangular container with a square base with a volume of 500 cm3. The material for the top and bottom of the container will cost 1 ringgit Malaysia per centimeter square, and the material for the sides will cost 2 ringgit Malaysia per centimeter square. First, you need to show that the total cost of constructing the container is CS equal to x square plus 4000 divided by x. Second, hence find the minimum cost of constructing the container.
Number 1, we must prove the total cost of construction the container is CS equal to x square plus 4000 over x. So CS equal x square plus x square plus AXY equal to x square plus AXY. Given volume is 500 equal x square multiplied with y. So y equal 5000 over x square. So CS equal to x square plus AXY. We replace the y becomes 2x square plus 4000 over x, 4000x over x square, and we solve and we get CX equal to x square plus 4000 over. Number 2, we must find the minimum cost of construction the container. So CX equal to x square plus 4000 over x. So C prime x equal 4x minus 4000 over x square. So let's C prime x equal 0 and then 4x minus 4000 over x square equals 0, and we solve and we get x equal 10 cm, and that we must do the second derivative test. And so the second derivative is C equal 4 plus 8 over x cube. So replace the x that we get before and with in the formula second derivative, and we get 12 is bigger than 0, so the positive. So replace in the formula Cx equal to x square plus 4000 over x, and we get to multiply with 10 square plus 4000 over 10. So we get the minimum cost of the construction the container is 600 ringgit.
Finally, we are reaching to the end of this video, which is conclusion. In conclusion, mathematics plays a significant part in our everyday life, especially in expecting and determining possible outcomes and values of something. This mathematical application has been used by architects, engineers, statisticians, and others to improve their work. Thus, it's important for us to not only understand the concept of differentiation, but we also need to apply it in our lives, so we could dive more about it to understand this topic even better on how it works.
Here are our references for this video. We have put these references in the description below if you would love to check it out. Thank you for watching and see you next time.